The way we're going to do this is we have a slide for the company with the person's name that is the entrepreneur. And so when we get to that slide, that'll be your opportunity to take the podium here and present. So the objective is, first of all, we're going to do a quick, very quick, like my name is, my company is, and then you've done a great job. Civet. And then you have an opportunity to present your company, right? So if you can all follow that pattern, then we can get through introductions, make sure that everybody knows who's up here, and then that'll give you the platform. Does that work? Everybody ready? All right, so we have 3 minutes per, and we're going to start with introductions. Ethan, if you don't mind. Yes, please. Why don't you just lean into that and share that?
Sure. Hi, everyone. My name's Ethan Barron. I'm the founder and CEO of Creative 3D Technologies.
Great. Thank you, Ethan. Perfectly modeled.
My name is James Ornstein. I'm one of the founders of Trinity River Community Solar Systems.
Hello, my name is Ki Han, CEO of Differential Dynamics.
Hi, my name is David Inbar, and I'm founder CEO of Dejalytics.
Hi, I'm Patricia Fryer, and I'm CMO of Konami Software.
My name is Stan Love. I'm a registered architect here in Texas and a part of a team, CDM Industries, that's going to promote a product today.
Hi, everybody. Pat Maher, one of the co-founders of CDM Industry, and we're going to present some modular building component concepts that we've been working on, and thank you for having us.
Thank you. Great. Fantastic. All right. So let's dive in. So, Ki Han, you they have the
I'm the first one.
yes.
Go ahead.
Yes, please.
I'd like to start with climate change, and we are blaming emissions. There are two ways to eliminate it. One is not producing it, and the other one is produce it but cleaning up. My choice is not producing. I studied hydros, coal turbines, gas turbines, and nuclear reactors. How much they look different, but I found a commonality. So to speak, Da Vinci Code was broken. The code is speed. So I invented speed converters. Speed converter control river turbines, generate base load. Base load means dependable, and you do not need batteries. We do not need dams to build. Low investment and good for migrating salmon. I do not need power grid. That means truly DER, distributed energy resource, or distributed generation. Gridless remote regions can be electrified. This technology can be applied to all kinds of MHK energy, meaning tidal wave, ocean current, even wind turbines. The cost of river turbine is the lowest in the industry. And finally, speed control river turbines produce rotating inertia to keep the grid power stable. So I built test samples and site tested, and the technology is validated by University of Manitoba, Canada. Next step is introducing to the market. Rivers are abundant around us, and river turbines can generate abundant clean energy. And I'd like to invite everybody to join us to fight the climate. Thank you.
Great job. I love it when people do exactly what you're asking. That was less than 3 minutes. Very, very good job. Very impressive. Thank you. All right, great. Next is Patricia.
There is a clock up there, so I'll try to keep that.
Okay, I'll give you 30 seconds.
All right, I'm Patricia Fryer. I'm CMO of Konami Software, and we provide a secure, resilient data mesh for the complex distributed networks. Now, I'm with a room full of people who work on edge computing, and that's what we help to secure and make the data resilient. But a little bit about the company. I'm a mentor at Capital Factory, and at the beginning of COVID, I left my old company that was in doing a lot of data analytics in the automotive industry, working with electrification, working with autonomous vehicles. And so when I wasn't marketing, I was thinking about, well, how are they going to secure the autonomous vehicles? You know, how are we going to keep data hacks from happening? I worked in early internet security. I've been in the startup industry in Austin for, it's coming up on 30 years now. My first startup was out of MCC, and we did early internet security, and we did we did a lot of firsts. So anyway, I've been in that. So that's why I was thinking about security. So when I met these guys in my office, they had a golden ticket to Capital Factory, and they're telling me about their security and saying, we can secure banking, and we can secure insurance, and we can secure this. And I said, wait a minute, with what you're telling me, could you take care of the data in autonomous vehicles? And they said, well, yes, we could do that. I said, okay, you need to start focusing on edge stuff. So today, you know, fast forward, what is it now, 4 years later, nearly 4 years later, I became an advisor, and then I came on board full-time as CMO. We've have great traction in the defense, the DoD right now. We've won a NATO Innovation Award for resilient data. We just were named a cool vendor by Gartner for edge computing. That's just like one of 5 companies named a cool vendor. And those are companies like I heard mentioned earlier, Dropbox and Uber, and those are cool vendors. So we're in that category. So we're doing things with securing critical infrastructure. We're doing things with search and rescue with drones and robot operating systems. And we're doing things in digital engineering. So I'm really glad to be here. I'd love to talk to you more about the technology because it's, you know, it gets down into the how does it work. Thank you very much.
Good job. Thank you. Okay, David.
Okay, thank you. Datalytics started out with a focus on analytics platforms and rapid development of predictive models and other kinds of simulation models. And then we pivoted away from that. We pivoted away because it became more interesting to focus on a particular vertical. That vertical was wholesale energy markets. So the grids, particularly the North American markets initially, ERCOT and PJM. And we've been focusing specifically on that in predicting wholesale energy prices in the short term. And that means everything from the next 15 minutes to day ahead for those of you who know those markets. Use cases for that are traders, of course, in those markets that need to hedge or need to make decisions, but also assets that are connected to the grid. And that includes natural gas turbines, includes batteries, includes solar farms, and so on. The issue that they confront is that with more and more distributed resources attached to the grid and more changes in the way that electricity is consumed and the scale of that in different parts of the grid, overlaid by climate change, is creating more and more turbulence, and you could say unpredictability in those markets and on the grid. What we deliver is the ability to anticipate those for particular use cases. One example is in the situation these days where traditionally you think about natural gas turbines firing up and then running for hours and hours and then firing down. The intervals during which natural gas or batteries are needed is getting shorter. And so the ability to fire up and power down at the right time is critical. So think about these models as part of a solution, not in the models themselves. So we've built the models, we've built the platform which they run. They've been running in the cloud now on AWS for over 2 years, 24/7. And they, in this particular use case, one of the use cases, they send signals to the generators to turn on and turn off. And normally that's a human decision, and that has to be done 24/7. That's difficult for people to keep up with all the different data factors that are going to drive that. So we've done that, and part of the technology innovation that we've also been able to work on and deliver is that you need new models every single day. And we've automated the process of building those models, selecting the right one or the right ones to deploy for each location in the grid, and deploy those. Again, all lights out 24/7. Love to talk about some more with any of you.
Thank you. Thank you very much. Good job. Next slide, please. CDM.
So we're so new, we don't even have a logo yet. So thank you for doing that. So let's see. Our promise as a company is to actually create modular building components that are good for the planet. So we're looking at some really big problems here, and we've come at this from a sort of a technology perspective. Obviously, carbon and climate change is a huge issue. It's subject of everything we've been talking about. I think most people here probably know that the construction industry is responsible for over 39% of the carbon deposition on the planet today, which is huge. It's completely disaggregated. Nobody's really doing anything about that. That's a big problem. The second problem that we're looking at is this idea of affordable housing. There's reams of data out there that show this to be a problem that that is also not being addressed or solved, and there's a lot of reasons behind that. And the third big piece is construction efficiency. So the construction industry makes probably the biggest industry that makes the least use of modern technology today, which to me, I don't come from that industry, is virtually appalling if you look at how little technology is actually being used and deployed. Along with the efficiency, there's a huge amount of headwinds in construction, primarily around labor shortages and things like that. So what we did is we said, these are big problems, but they're also big opportunities. We spent a lot of time looking at how we could sort of maybe unlock these, get the key to unlock. So we came up with a product line that we call Keezy. And it's a line of modular building components primarily targeted at single family or residential type applications. What it does is it allows us to build components, building blocks, if you will, in a factory. The building blocks are wall panels, they're plumbing and utility walls and cassettes. The most challenging part of any building are the MEP systems. If you think about how the MEP systems are built and designed and integrated today, it's completely a bespoke process. There's no scalability, there's no repeatability, there's no real quality standard. Even houses today from big builders, the same model that's repeated are completely bespoke and different. There's a huge waste problem that comes out of that. A lot of it is because the ground systems, soil is a huge variable today. And you've got to take that variability out of the MEP system. So we have a line of products, mainly the utility products that you can basically build and plumb in a factory and install them in such a way that it takes out the equation of the foundation and the dirt. Stan, my partner here, is an architect and engineer, and we've worked together many years on this to come up with it, and we think we have some real novel solutions around there. And welcome any continued conversation or curiosity around what we're up to. Thank you, guys.
Very nice. And then Ethan, Creative 3D.
Hello, everyone. My name is Ethan Barron. I'm the founder and CEO of Creative 3D Technologies. Just want to mention I love the topic of decentralization, decarbonization, and digitalization, since that is a wonderful summary of a lot of what my startup's trying to do. We are trying to decentralize and distribute the manufacturing power by making single cell manufacturing, which essentially is a technology that's been deemed impossible for well over 4 decades, but essentially takes your whole manufacturing line that you would have somewhere else off-site, like Asian country, for example, and bring it into a single unit that's capable of making a vast majority of products end to end in a single unit that you can, as long as you give it the right input and have power, can make that full product end to end essentially wherever. And we've been having a lot of exciting success doing so, both through digitization of people's inventories and supply chains, where instead of needing to order a lot of these parts again, we're actually able to make them in-house, but also do so in a sense that keeps decarbonization in mind, since we're able to and have had experience in making full net negative products, because we're able to process raw ocean waste or do a lot more sustainable materials like algae-based thermoplastics and things like that within the parts themselves, which has been wild experience. But we've been developing this since well over 6 years at this point, and it's exciting since our first single cell platform has finally hit the markets recently, initially starting with the moat of 3D printing, as a lot of the technology is kind of built around that, but has quite a bit of other manufacturing cells built into it. But essentially, we build a platform that has the speed, tolerance, precision, torque, UI, electronics to encompass most manufacturing platforms, and do so in a several foot by several foot area, but have it be all modular, where instead of, like I said, initially we're attacking 3D printing, we're doing what would be a $6.2 million suite of 12 plus specialty industrial machines, typically separate functions in one cell, but it also can support much stronger tools, so you can swap in additional types of manufacturing in it. And we've gone as far as even doing drones for the DoD, where we've made a full thing end to end with carbon fiber. We've built in pockets, dropped in the motors, picked up the semiconductors, built them into the part itself instead of needing assembly, did silvering tracing to wire to things, and essentially everything minus firmware, smoothed it out, polished it. We even compressed what typically be a 12-inch by 12-inch board and compressed in less than 4-inch by 4-inch cube, created like the full drone right off the machine itself, and done so for a lower price than a centralized Asian manufacturer would typically, for example. But we've been doing well. We've got about 500,000 revenue and are looking to expand now, since even though we've been around for 6 years, we are a little earlier stage where we just have lighter production going right now. So we're closing a $1.5 million seed round and are at the about last 200,000 of it. So if anyone might be interested or know someone that could help us expand, since we have some of the largest manufacturers in the world demanding thousands of these things, and we can make 5 a month right now. Growth is certainly the focus right now, and that's where we're headed. Thank you.
Very nice. So pull out your checkbooks. I think they're all thinking that, so hopefully you brought them. And then James with Trinity River Community Solar Systems. And I'll stay here while you use that panel.
Okay. My name is James Ornstein. I'm here to present Trinity River Community Solar Systems. I'm the co-founder. I have one other co-founder, and we have some other people that are basically, we can bring them in when we need their services. So we started off in taking advantage of a DOE program called the National Community Solar Partnership. So they've been helpful in providing technical support, and they have a number of other programs that they're doing to try to encourage adoption of community solar throughout the United States, and particularly in states which don't have any enabling policy or legislation, which is Texas. So they have an actual goal of having 5 million households and $1 billion in cost savings by 2025, which is pretty aggressive. So in any case, we're trying to do our part in enabling that in Texas. So the the pitch that we have is, and again, we're a startup and we're early stage and we're a nonprofit, so it's a little bit different than looking for investors. We're looking for people that can help us, that have some expertise in some areas where we're a little bit weak, and then we can accept donations through some online platforms if anybody would care to do that or talk to me about it, personally. So in any case, the idea is doing aggregated community solar and storage using blockchain transactive energy. So the problem in Texas is that there's a lot of solar, there's a lot of utility scale solar, there's some residential, although not like in some states. So if you want to do community solar, and community solar is defined in various ways, but basically it's a what I would call a commercial industrial scale installation, and it's somehow or other benefits the local community. So the idea is in order to make that cost competitive, you're having to compete against the large utilities on one end and people that can install solar on the rooftops in the other. So the way that we think we can get that to work is by using blockchain for doing transactive energy, which is, it's fairly big in Australia and Eastern Europe, and there's a company called Power Ledger that we're planning to work with when we get some projects going. There's another company called Dione Protocol, which is more of a startup that's operating in the same area. So that's the basic story, and I can fill in the details. And thank you very much.
All right, great. Okay, so thank you for all of your presentations. We have a few minutes to have some Q&A, so I'd like to open it up to the audience. If you have any questions about any of these startups, you'd like to probe a little bit and learn more about the company, the market they're in, now's a great time to do that.
I would like to know if they can go through, Ethan did a great job telling us what he's looking for.
Yes.
What are the others looking for in
Great.
capital?
Thank you.
Capital are they looking
Yep,
for?
we'll start with you first, James.
So at this point, we're through the National Community Solar Partnership, they have financing for actual projects. They have a platform for developers sign up and people that are doing financing. What we really need is a smaller amount of money just for operations and to basically keep us going. The technical support that we're looking for again is somebody that knows a little bit more detail about the blockchain transactive technology. I know enough about it to be dangerous, but in order to work with the companies that do know a lot about it, it would be helpful to have somebody that understands it better. And the other thing we're looking for is there is a pilot program for doing aggregated DERs in Texas, and it just kicked off in November, and it's been made sort of famous by Tesla, where they call it their virtual power plant. And they made a lot of news because they announced it at the same time that there was a kind of electricity shortage and spot prices went through the roof, and that worked out well for them. But so in order to participate in that, you need some people that understand a little bit more about the wholesale electric markets in Texas, and signing up with a Queasy and becoming an RAP. So thank you.
Thank you. David?
Sure. In particular, we appreciate introductions to corporates that are significant users of electrical energy. That could be industrials like steel manufacturing, concrete, or could be real estate, commercial space, and so on, in order to partner to build out more of the demand response use cases that can contribute to not only reducing these companies' electricity bills, but also to their carbon footprint, because there's a strong correlation, not an exact one, but a strong correlation between high electricity prices and carbon intensity.
Great. So some commercial corporate introductions. That's what I'm hearing. Yep.
We have advanced technology. We are ahead of everybody else. So in a way, there's a blessing to us, but NIH factor, not invented here, syndrome is very strong. So our marketing strategy is not selling the technology, but actually showing the samples, river turbines, how it's working. So our expenses will be mostly convincing our potential customers.
Got it. So not looking for capital, looking for help with marketing, or do you need capital?
Basically, our expenses are building samples and showing, installing to their sites so that they can see how good are the performance.
Okay, got it. Okay, thank you, Patricia.
We've been working, as I said, in the DoD space and developing our software. We are planning to go to the commercial market in 2024 and plan to do a round at that time. What we do is we're secure infrastructure for data. So we manage data, we provide protection and security and resiliency, which means if it's valuable data and you don't want to lose it, this is what's needed as an infrastructure at the edge. So if it's not valuable data, we're not needed, but say in robotics, anything like that. So we're looking for pilots as well. So anyone who's working in robotics is a good area, drones, interesting 5G applications where things are dangerous, looking for things like that. Thanks.
Great, thank you.
Let's see. So we have prototyped and built the key module products that we have, validated them, pretty happy with it. We've got 3 major builders that are interested in utilizing this, so we're seeking about $1.5 million to build out the units. We're thinking it's probably 10 to 12 systems to build out, field install, and propagate those through our first beta customers. Thank you.
Perfect, thank you. Great. Did you have a question?
I had a question just for the one with the robotics. Are you focused on generating pilots locally or anywhere in the US of A?
Before you answer that, let me repeat the question. The question is for Patricia. Are you looking for robotics? Are you looking to do those locally or across the USA or wherever? Yeah.
Anywhere in the US or allied countries.
Great, thank you. Other questions? Oh, yes.
I do have a question for the architect, if I may. Can you expand a little bit about what particular type of architecture you're talking about? Are we talking single family, multi-family, and so on and so forth? When you talk about trying to offset, carbon infrastructure and so on and so forth, more and more countries are talking about eliminating single-family homes, yet building multi-family homes often requires concrete, which is the very problem that we're trying to offset.
Yeah, exactly.
Before,
I'm trying to figure out a bit more. Tell me what exactly you're doing.
hey, Pat, before you guys answer that question, let me repeat it for this folks on. So the question is what are the use cases or applications, and specifically, are you doing single-family or multifamily or other? And because multifamily has a demand for concrete, which creates carbonization challenges, the question is just curious about that carbon footprint.
Okay, I'm going to start out. I guess the short answer for you is I think the focus primarily at this point, single and multifamily. The products themselves meet the standards of type 1, type 2 construction. So non-combustible, we could literally use them anywhere, but I think the focus now is just on housing. Gosh, we only have a few minutes here, and there's been over a decade of research and development into what Pat and I are trying to promote, but part of it is parts. I've learned a lot from this today, but we're kind of backing up a little bit in that we do have a product, a U.S. patented invention that's a key core, utility core, where everything is mechanical, electrical, plumbing, everything is compacted. In fact, Pat had mentioned the laboratory is up in North Texas, but the prototype's been built. There's been one sold, but the idea is that, yeah, we have great innovation in what we're trying to accomplish, and we're just simply trying to prove that out in the market right now. But if you can imagine, most of your utilities, it's a plug. The gentleman that was on the screen, plug and play. It's definitely a plug and play. I had that term years ago. It literally runs everything horizontal. So imagine clearing out anything vertical below or above.
Also, what maybe more to your question about the materials. So we're using light gauge steel structures that are actually 3D CAD formed to build the structure for it. And the way the systems work is they actually alleviate the need for foundational intricacies or complications, if you will, that lessens the amount of concrete that's required. So you still need a concrete foundation. We've got some other things we're working on for that. But the systems themselves use light gauge steel. The light gauge steel comes from recycled cars. So essentially we're repurposing garbage to build, components of houses. And we think the components actually apply to any building type. We have started and focused on single family and multifamily. As you go beyond 2 or 3 stories, some of the complications of those systems get much more deeper and sort of challenge some of the theories that we have already. But we think in terms of single family home, multifamily, workforce housing, slam dunk for those type of things. And the sustainability and the environmental elements are definitely a key thing. So thank you for that question.
It's a good question.
Great. Andres.
I have a question for Ethan. Ethan, can you explain your latest product? What does it mean when you say that it's single? How do you describe it? Can you build a 3D printer with your 3D printer? Or can you explain more of that?
Yeah, what is single self-manufacturing? I think is what you're...
Yeah. So happy to, I think I was kind of touching on the latest product too.
Yeah.
The latest product that we have is, like I said, it is a single cell manufacturing platform. Just the first moat that we are attacking is 3D printing, since it is a $22 billion market that's growing at a 30.2% CAGR, that with a product that we can price at $25,000 and be more than $200,000 lower than the closest competitor that does 1/10 of the function, it gives us a open end to eat a lot of market share and position ourselves in an industry leader position while individually outperforming what that suite of units would do. So it's very hyper specialized in the sense that if you want to do a large part out of tungsten, titanium, or Inconel, you're probably buying a $3.8 million machine from Desktop Metal, and that's going to be very different than what's going to do 316 or 17.4 steel at your $1.2 million price point. That's different than what's going to do carbon fiber, food, ceramic, your thermoplastics at a super finite coin face precision detail, or everything in between, because there's one supplier that makes one type of printer for one kind of price point. So in doing so, we can attack a lot of it, but the core and basis is still there to incorporate different cells and different types of manufacturing instead of just printing. So we've experimented with doing a lot of thicker layers on a print and then having subtractive manufacturing smooth it out to make it look like an injection molded part, or do your plastic layers but then actually drop in your circuitry of pick and place and also wire it together using silver ink tracing and bring in more things that would be very expensive separate cells on a production or manufacturing line, bring into one unit, ultimately drops your product costs on a manufacturing line. You have to factor in the cost of each one of those machines, labor, even if it's inexpensive overseas labor, and then the shipping and all the pollutants that are included with it, versus just making the one product and then actually giving it like a manufacturer certification, because we eat more data than any other manufacturing tool out there. We know exactly how much materials requested we output, how much is actually output, and cross-compare it to your CAD model to ensure it's to size, and we can give it essentially like a manufacturer guarantee.
Great answer.
Thank you.
Got a follow-up.
So how big can you make a part? Keegan wanted to build a river turbine using your system. How big can you make?
So the unit that we have right now for $25,000, you can do about a meter by about a bit more than half a meter by, again, almost a meter. So that is kind of your volume. Anything you can fit in there. A lot of people end up building multiple components if you have something very large, like larger furniture pieces, and you can just combine them together afterwards, though we can make it larger and there is demand too, but right now we're trying to keep up with the initial demand we have already right now with the current size. Thank you.
Yes, sir.
While we're at it, how flexible is that whole system? Can I change over to a different way of producing, or is it, once it's established, kind of chill and stuff?
Let me make sure.
Sure.
everyone-
Yeah.
So how flexible, the question is, how flexible is your system? And can I change processes, or can I, does it have flexibility to give me, I guess, flexibility on different use cases?
We've made it super easy. Essentially, instead of having a manufacturing cell or a different tool that you would, send to the next line in a production line, we've compressed it into essentially a single smarter board that we built into the tool itself. So if you're trying to do additive and subtractive, basically on a subtractive with your milling spindle and everything else that's in there, we've built it onto a tool that has kinematic mounting plates, so you can pick it off and magnetically pull it off within about and put it back on about 3 micron of repeatability. But you plug in a single, looks like an Ethernet cable, plug it in there, and plug in your power cable, and that's all you need to, and you can swap tools and swap manufacturing methods within 20 seconds or less. And that's the initial platform. We have something a bit more in depth that we're releasing closer to 2027 that is autonomously doing that swapping for you. So it will have a higher price point, but can do so between, I think it's 20 different modules is what we're looking at, instead of just autonomously incorporating more than 2 is what we're currently doing. So
good. Thank you.
Can you elaborate real quick, Ethan, on what have you made that you're using? What kind of things can I make that you're using? And is what you're making stronger than what I could buy as a part? So we have a maker space here. We have, laser cutter. Our kids are making pistons that go in the engine. Can I make stuff like that with your thing?
So let me make sure we heard it. So the question is, how flexible is it, and what kinds of things can I make? And we have a facility here at Cedar where people are, makers are making things, and can we use something like what you're talking about for those different applications?
Yeah, certainly we have folks that use them in maker spaces already. There's one over at ACC, and people are beating up for similar reasons, except if you look at a lot of maker spaces, you'll probably have multiple different printers, and if you're trying to do different formats, different temperatures, if you're trying to do like a super flexible material versus a very rigid one versus a carbon fiber, like I said, you're probably going to have a lot of separate ones, and instead you're teaching kids to use one interface, which is a lot easier to use and something that's built to be reliable from the ground up, and you have a lot less of the problems. But in terms of flexibility of what you can make, we've seen quite a bit. Our idea was to try to approach and make this as relevant to as many people as possible, and that's because partially why we have it at the price point we do, even though it is substantially less expensive than anything else that's out there. We did so because first of all, the only way you can make this is using our proprietary in-house manufacturing methods. So it's tough for someone to compete and try to make something that can compete just through manufacturing alone, but lets us empower people's creativity without a lot of constraints of price behind it. But we'll see anywhere from Michelin star kitchens trying to put in chocolate, and then if you want to feel fancy, need a polygon they filled with whatever cream they made that day, you can do so because the thing's been built to be food grade safe too. And we've had while I printed the control arms on my drift car, so I ensure my wheel's 80 degrees, and it's survived over 14,000 miles of wear, tear, and aggressive assault on a drift track as well. And done so for, it cost me more than 60% less what it would cost me to typically buy the part. I made it stronger and lighter, and it looks a lot nicer. And I can get more angle than I would a typically purchased part, but we'll see anywhere from that to, a lot of it's prototyping where we'll see a lot of it. For example, the company that's doing the gel blasters you see everywhere, it's doing like the Orbeez you fill with water, kind of like a Nerf gun for a lot of kids. It costs them, I think they said it was over $60,000 to prototype a single gear profile for that. And if they can buy a $25,000 unit and print that gear, because no printer really has had the right precision and strength combination to make a lot of functional gears like that, they haven't had a way to approach that prototyping, though with ours, we demonstrate it by printing the full finished unit. We'll see everywhere from industrial parts. If there's a CAD model of it, our goal is to try to be able to make it if we can. So
thank you. Other questions?
Yeah, maybe you could talk a little bit about what your 12-month trailing volumes have been and what your backlog is.
Sure. I don't know how much of the backlog I can actually talk about. Some of the things are finalizing right now, which has us.
Maybe just summarize just like the, unit volume or dollar volume or something so we can get
whatever
it
you're
simple?
comfortable with. I
Yeah.
certainly don't
Sure.
High level.
Well, the easiest way would probably just be to reference our HubSpot. Essentially, a lot of folks have come to us either at trade shows because we've broken taboo. We've told people at these shows, which most of these units you can't get close to, much less touch, because there's an engineer watching every line of code, making sure the thing doesn't fail. And we've told people as a no-name startup, as our way to do our design study, I mean, we figured the best place to really see if someone's going to break it is the area that everyone's looking to buy a new printer because theirs are broken. We told them, you know, quote, beat the shit out of it, unplug it, rip it apart. If it breaks, don't worry about it. We'll get back to you in a week, not like fixing it, but improving it. That's turned a lot of heads, and there are thousands of names on that list that want anywhere between 1 unit or 4,000 at the maximum per name on that list. We've had folks come in and redesign every single line of our production line. They've gone through all the steps to try to make it more efficient. So we are currently able to do around 4 to 5 units a month with our current setup, but the reason why we're raising is so we can start affording the minimum order quantities that some of our larger manufacturers want from us, but also because the only way we can scale production of this is in-house, because we've been shooed away by other manufacturers telling us we're crazy if we think this is manufacturable. So our in-house scaling needs to be done, but we want to test that line, which is why we haven't factored the orders to do it instead, and we want the added burn to do so, which that can do upwards of 100 a month once finalized. So that lets us keep up, and then once we finalize that, we can start to, because it's then qualified, lay down another line to more linearly scale from there.
Hopefully that answered your question. There's a little bit of extra credit in there, and that's good. Any other questions?
The CDM,
Yes.
what's the company? Industries.
CDM Industries.
CDM, yeah. But you guys are in Dallas?
Yes.
Okay, and you're gonna build, you already have a place where you're gonna build stuff?
Yes. We're also targeting the Texas Triangle, which is pretty well known.
Yeah.
In terms of, builder density and stuff, all the top builders are in this area.
We're open for business down here.
Yeah, right. And so, it's a target-rich environment for sure, and especially with the way the economy is now and the interest rates, these guys are really starting to think about their business and how to become more competitive and how to sort of streamline some very archaic and very old school processes that they've been using and profiting handsomely off of in the last 5 to 7 to 10 years. Sure. Those days are gone for the foreseeable future. So good time for us.
Any other questions? Well, let's use our time that we have left, first of all, to thank all of the participants and all of you for being here. And I invite you to come meet them. That's part of the objective, is for you to come meet them and ask some more questions in person. And if you're more comfortable doing that, or if you didn't want to share your brilliant question and you want to make sure you get that investment in, come on down. All right. Thank you very much. We're going to do a selfie. Come on. So everybody.